2.1.5 Project Life Cycles. Now, learning objectives. This section introduces life cycles, which are fundamental to the management of any project. Organizations will often set a standard approach for project delivery, depending on the desired outputs, benefits and outcomes that are expected. By the time you have studied this section, you will have completed the following: learning outcome assessment criteria to understand project life cycles. 2.1 State the phases of a typical linear project life cycle. 2.2 State the phases of a typical iterative project life cycle. 2.3 Define the term hybrid life cycle. 2.4 Define the term extended project life cycle. Whatever life cycle is chosen, it will provide a structure for governing the progression of the work by acting as an important management tool. It will allow focus on the allocation of resources, the integration of activities, the availability of key individuals, the support of timely decision-making and the mitigation of risk. Additionally, the life cycle also allows the provision of control and governance mechanisms matching the life cycle structure. Consequently, it is important that sponsors and project managers understand the characteristics and specific features of the selected approach. Approaches to deployment range between highly predictive and highly adaptive settings. The choice between predictive and adaptive philosophies is largely influenced by the availability of knowledge. More predictive approaches tend to rely on knowledge identified at the start, allowing work to proceed in a sequential manner, while adaptive contexts imply that new knowledge is created as the work progresses, which is then used to inform and guide the remaining effort. Adaptive approaches allow more key stakeholders to contribute and shape the development process. Phases of a typical linear project life cycle. A project progresses through a sequential series of steps, known as phases, from start to finish as shown in Figure 2.1.5.1. Each phase provides only partial capability until the final desired state is reached, usually at the end of the last phase. This is suitable for stable, low-risk environments. When the project scope is defined, the phases may be subdivided into smaller elements within the timeline, referred to as stages. Figure 2.1.5.1 Linear Project Life Cycle. A typical linear life cycle encompasses multiple phases: concept, development of an initial idea through initial studies and high-level requirements management, and assessment of viability, including an outline business case. Definition, development of a detailed definition, plans and statement of requirements that included a full justification for the work. It would be typical for a project management plan to form the output of this phase. Deployment, implementation of plans and verification of performance now through testing and assurance to release intended outputs, outcomes and benefits. Transition, handover, commissioning and acceptance of outputs to the sponsor and wider users, culminating in formal closure. The linear approach aims to be highly structured, predictable and stable, providing a transparent format for managing contracts and allowing maximum control and governance over the process. It works particularly well for undertaking the delivery of well-understood and clearly defined outputs, trading time, cost and risk to achieve the right scope and quality. On the other hand, it assumes the availability of relatively perfect knowledge upfront, while being resistant to change and inflexible in terms of corrections and rework. It also implies a long sequence, culminating in the ultimate handover. Dividing knowledge into distinct phases in this way can often create silos and knowledge barriers between the phases, particularly when different delivery agents will deliver different phases. Those carrying out work in the deployment phase may have a tendency to blame activity in the previous phase for any problems they encounter while delivering their assigned workload. In addition, they may have very little incentive to pass on learning to help those delivering pieces of work further on in deployment. Phases of a typical iterative project life cycle. Iterative project life cycles are most commonly used in Agile development projects. Agile is a family of development methodologies, where requirements and solutions are developed iteratively and incrementally throughout the life cycle. The life cycle used in an Agile approach is composed of several iterations, allowing the deployment of initial capability, followed by successive deliveries of further value. They are based on the idea of concurrency, or simultaneous engineering, where different development steps are performed in parallel. Iterative life cycles repeat one or more of the phases before proceeding to the next one, and manage uncertainty regarding the scope by allowing the objectives to evolve throughout the life cycle, as learning and discovery take place. Prototypes, time boxes or parallel activities are used to acquire new insights, obtain feedback or explore high-risk options. The scope of this activity depends on the level of uncertainty and the organizational appetite for risk. The duration may extend throughout deployment. Figure 2.1.5.2 Iterative Development in Dynamic, Agile Context Source, DSDM Agile Project Framework Handbook, 2014. There are 6 phases in an iterative life cycle, and these are shown in Figure 2. During the pre-project phase, iterative life cycles begin by developing a high-level vision. The feasibility and foundation phases ensure that the finer detail is uncovered during the cycles of iteration. The evolutionary development phase allows the specification and design to run in parallel, and so it fast-tracks to deployment. Iterations are thus used to progressively elaborate and improve understanding based on client interaction with learning between the iterations. Iterations are applied when the goals are clear but the means of achieving them are not. The rapid deployment of smaller, partial solutions becomes the basis for gaining fast feedback and new insights about what needs to be done. Iterations are often conducted through working prototypes that stakeholders use as the basis for adaptation and improvement. The deployment phase seeks to bring the evolving solution into operational use either fully, or using an incremental solution that delivers partial requirements, using user experience to form the next solution increments. The final phase, post-project, identifies whether the solution has delivered the benefits to the degree required to achieve the business case. Overall, using iterations allows earlier return on some of the benefits that have already been implemented while validating the concepts and engaging users. The term hybrid lifecycle. There is no single lifecycle model that would suit all applications. The choice is dependent on what the organization is trying to achieve and what aspects of the project are important. Hybrid life cycles, therefore, enable a pragmatic mix of approaches, typically fusing together elements from predictive and adaptive perspectives, to create a new model or approach. For example, using iterative or agile methods for early requirements gathering, where the uncertainty is greatest, and following it up with incremental or sequential processes, derived from the 2 previously mentioned lifecycle models, to formalized deployment, as shown in Figure 2.1.5.3. Figure 2.1.5.3 Hybrid lifecycle. The use of prototyping, time boxing or iterative thinking offers tested methods for experimentation and risk reduction. Adding iterative elements to predictive projects can enhance deployment in stages, support the generation of insights, underpin the realization of an early benefit stream, and validate some of the ideas much earlier in the cycle. Blending, merging or mashing of life cycles, ideas, principles, practices and methods can apply equally to programs and portfolios. Building agile working into a project or program can offer increased efficiency and flexibility. However, it also requires great skill and clarity when using multiple different systems of working. The term extended life cycle. Depending on the particular scope of a project and what it is delivering, the life cycle chosen can present a number of considerations. Some projects will be part of a program, and will be concerned with coordinating the delivery of multiple outputs. Some projects will work as standalone projects, and would be primarily concerned with delivering their outputs only. Other projects will be expected to incorporate the management of change and the realization of benefits, and hence require a greatly extended life cycle, as shown in Figure 2.1.5.4. Where a contractor is working for a client, the contractor's project may simply be the deployment and transition phases of the client's project, and will include the capability for benefits realization. In these circumstances, the client is responsible for operating the outcomes in a manner that will obtain the desired benefits. In this case, the host organization must ensure attention is given not only to managing the project to closure but also focusing attention on the operational phases, effectively extending the life cycle. Note Figure 2.1.5.4 Extended Life Cycle. Extended life cycles ensure that accountability and governance of the investment stays with a single organization until the change is fully embedded by offering the missing connection to benefits realization, while preventing the formation of knowledge boundaries between project teams and operations. Recognizing that many projects are initiated in order to deliver change and beneficial outcomes to organizations, life cycles can incorporate a further phase named benefits realization that may proceed up to the achievement of the business case. An additional underpinning phase is also required in order to release benefits, as new outputs need to be made available and accessible to potential users. This may need to be enabled and operated separately. The additional activities included in the extended life cycle encompass adoption, operations and sustainment required to utilize the new project and enable the acceptance and use of the benefits. Benefits realization. Realization of the required business benefits. The principal implication of extending the end of the life cycle to incorporate benefits realization is that there is a need to start upfront, planning for the supplemental activities, and incorporating additional considerations during the concept and definition phases. There are income and operational costs connected to the additional activities, as well as no-spending capital expenditure considerations, which will be addressed during the concept and definition phases. Null.